Well, thank you for joining me on this question. I'm going to be looking specifically at the last part of this question because I've answered the first question in a previous recording. And it says an amount of $100,000 is invested at an annual interest rate of 6.25% per annum. If the interest rate is calculated, now we've done part A, I'm going to be looking at what is the answer if the interest rate is paid monthly. So rereading that question, if the interest rate is paid calculated monthly, so I'll put here monthly. How long before the investment is reached, so we don't know how long, before the investment is reached $150,000. Now I'm going to put this as the amount, and I'm going to change this first value as our initial value, which is the principal. So in the formula, we've got a compound interest formula. A is P, 1 plus R over 100 to the power of N. Now, because N we're dealing with is monthly, we need a rate. Instead of 6.25% per annum, we want 6.25% divided by 12 per month. So let's just get the calculator. Oh, we'll just leave it at that for now. So R is 6.25 over 12. Let's substitute. We've got 150,000 is the amount. 100,000 is our principal. 1 plus R is 6.25 over 12 and over 100. And N is the number of months. Let's take 150,000 and divide it by 100,000. And we're left with, and I'll just work this out because I can on a calculator. I've got my iPhone. I'll put my calculator on. And do I have to turn it around? Not really. 6.25 divided by 1200, and that is plus 1. So it's 1.005208. Well, is that 3 recurring? It possibly is. 12 is a divide by, we've got a 3 in there, so that's possibly recurring. And to the power of N. Let's make it on the side. Yep, I've rotated the calculator. It does recur 3. Now, this is 1.5, and this is 1.0052083 recurring to the power of N. This is called log index notation, and what I'll do is turn that into log notation, and therefore the log, the base is 1.5, the base is the base 1.0052083 recurring, and the number is the log of 1.5 is equal to N. So there's the index, it goes here. There's the normal number, it goes here. And that looks a little bit out of place. I'll just put the dot above there. Little dot above the 3 for recurring. Now let's use the log law, which says, there's a log law which says if we've got AB to the power of N, that N can come down the front and multiply by the log of A to base B. So really that can come down the front to be here. We're going to do that to this. No, we're not using that rule at all. That's not the rule we're going to use. We're going to use the change of base rule. Well, let's write down the change of base rule. So the change of base rule says that the log of, say, base A to base B could be, we could change the base to make the log of B the log of A, and we could put any base here we want. Let's use K. Could put any base there. I'm going to use a base 10, so this is the change of base rule. Let's use that rule, and so that it will be the log of 1.5 over the log of 1.0052 083 recurring, and that will equal n. Put this in our calculator. I've still got my calculator on and on its side. So the log of 1.5, the log 1.5, and divide that by, I'm going to use base 10, so I don't have to write the 10, divided by the log of 1.0052 08 and 3's, and that's the log, and hit equals. So we've got approximately 78.05 months. Well, that means therefore it will take 79 months before we get over 150,000, because it's not quite there at 78 months. And there is our answer. I hope this has helped. Until next time, stay happy.